Yeah, as you saw, as you said before, very long title, so lot of content to discuss. So let me just go straight to the point. Yeah, I can skip my presentation. You already did a great job. Anna already presented the book, so I don't have to say much more on this. It's really a book that we wrote for developers with a developer mindset in mind. So if you are new to Azure SQL, or if you are new to developer at all, to development at all, yeah, I think this book will be really perfect for you. This is the book I wish I would have had when I started, developing for work. So I really hope that this will help you and help anyone that who wants to start the development career. Now let's go to the real the real meat of this session. And as you can see, there are several important points here, and all of these points are related to how to make sure that your application that you are developing or moving from an existing application that maybe you are moving in from on-premises will actually have the best performance in Azure SQL. Because the environment is very, very similar to on-premises, but there are some infrastructural differences that will emerge, and then we need to take into account in our code. So let's start with the easiest one, resilient connection. You really have to start to keep in mind that this connection will happen. It's not a matter of if or may happen. No, some disconnection will happen. Now, we try to do our best to guarantee 99.99% or even more of availability, but that doesn't mean that you may be disconnected for any other reason. It could be the internet provider, it could be a glitch, it could be in the connection, it could be yourself alone that decide to change the SLO and to upgrade or downgrade your database. So this connection is something that we need to make sure that our application is able to handle nicely without surfacing any error to the end user. There are several ways we can do that. Do it yourself is probably the most complete and probably also the most complex, but is the one that I will show you because it's really a good exercise to understand what happens behind the scene and what kind of error we need to take care of. Once we know how to do that, then we can use some existing framework that basically allows us to make it easier to implement a retry logic, Polly for .NET, Tenacity for Python, but there are basically for any language. If you want to have more details into that, besides the demo I will be showing in a few seconds, there are a couple of articles that we wrote, both on .NET or in general on Azure SQL, or for example, for some specific language in which managing connection could be a little bit trickier than the other, like for example in Java. So you should be covered no matter what language you will be using. Having said that, let me just stress out the highlighted part. Microsoft.data.sqlclient should be the client you are using to create your application. System.data.sqlclient is in a kind of maintenance mode because all the new feature are actually developed and will be developed on the Microsoft.data.sql client, which is really a drop-in replacement for system.data.sql client. So if you are migrating, you can literally remove system.data, replace it with Microsoft.data, and then the SQL client will behave like the same, but will offer all the new feature and support for all the cool features that will come in future. So let's move to see the demo in action. So before going to the demo, actually, let me show that all the demos I will be showing you today are available already online. So you can just go to this URL. It's also in the slides, and you will find all the demos I will be showing. So that's a great way for you to just experiment what I will be presenting after the session. Having said that, I already have, of course, clone the repository in my machine, of course, and then I can just go to the samples, and let's go to the resilient connection. And inside here you have several options already: .NET, Python, and just generic SQL. So let's go to the .NET, and inside here we have two examples. One called simple, and let's start with that. one a little bit more complex. Now, the simple one is just to show you that without doing anything, if you use the latest version of Microsoft.data.sqlclient, you already have the ability to automatically recover without literally changing any line of code in your application or writing any additional code in your application from this connection. So this is the demo. I will be connecting it to my database, and then I will just run we'll just run a very simple select command, right? After that, I will create another thread and kill my session. So I will have a connection, I will spawn another connection, the second connection will kill the first one. And after that happens, the first connection will try to execute something again. But of course, the connection will be severed, right? So there is no connection to use. So what you would normally expect is an exception. We will see that with the latest version of Microsoft.data.sqlclient, we don't have to do anything to keep the connection open, or actually, even better, to reopen the connection. And then we will try to run exactly the same code again, but with the automatic or what we call idle connection resiliency turned off, which we can do just by setting connector retry count to 0. And let's see what happens. And in that case, we'll get an error, of course. So let me run. Oh, what's happened? Okay. Weird places. Okay. .NET run. So it will start right now to connect, and of course I have my connection here. So for example, I can just go here. For example, I should have already. Okay, here. Nope, that's not one. Okay, probably I closed it. No big issue. I'm in the lab database. So let me switch to lab, and I can do something like. So just to see which session are actually active in my Azure SQL, and you will probably see Hyperion is my machine. So you see that there is a connection open here, right? Now, so everything is exactly how I would expect to be. So I can now kill my connection, and after the connection has been killed, I will try to execute the application, try to execute the program again, the query again, and the query answers perfectly. So no one recognized or were able to notice, so if I were the end user, that some disconnection was going on. Now, what if I disable this connection resiliency by setting the connection retry count on in the connection string? You see I have my connection as a 105. So if I go here, I see that I have my connection, perfect. And now if I kill this, as you can see, the second time, an error is surfaced because I'm not really managing anything here. I'm not doing a try-catch block. I'm not managing the exception in other way. So here I'm just simply doing, the worst of the worst, I would say. So no exception management at all. But even in that case, idle connection resiliency basically saves the day, because even the worst case, the end user doesn't notice anything. Now, this is the easiest one, and of course, only we basically can do that only when we notice that there is a connection open, and the connection is not running any query, right? So in that case, we recognize that that is an idle connection, and so we can actually automatically reestablish the connection and run the query when you need to run it. But of course, there are more complex examples, right, in real world. So we want to move to the advanced sample here, where I created a much more complex example, much more realistic, where we have, and here I have explained everything here in the README, where we have actually, let me go to the README, and here. So the application will simulate 3 different conditions using three different threads. The first thread just simulate what happens if you apply the best practice, where you open the connection, execute the query, and close the connection. And you open the connection and close the connection only when you need it and as soon as you have used the connection. So basically, open connection, execute query, close connection. No dead time between all these steps. The second thread actually simulates the case in where you open a connection, then for any reason you don't actually use it, so the connection is left open, you do something else on the application, or maybe the application is just slow, so let's say 2 seconds passes, and then after that 2 seconds has passed, you actually execute a query. So there is a delay between when the connection is open and when the query is executed. The third case and the third thread is when you open a connection. As soon as the connection is being opened, you execute a query, but the query for some reason is really long, like it takes 2 seconds to be executed. Now the question is, what happens if there is a disconnection in any of these 3 cases? How we can recover safely? What will happen in 3 different cases, so that we can learn, first of all, if it's really so important to open a connection only when you need it and close it as soon as you have finished using it. And we will see that this is really important with our own eyes. And if for any reason we can't do that, what we can do to save the day anyway. So let's start the example. Let me just go here and first of all, let me go and comment the code. So this in the code, there is a list of errors that we know are transient. So we need to make sure that if any of error of this happens, we actually retry, because these are network error, database not available error, anything that can be related or to network not being available, or DNS not resolving the name, or disconnection due to the fact that Azure SQL is going through a recycle, for example, when you upgrade your database to a higher service level objective. Then here I defined how many times I want to attempt to automatically reconnect, and how many seconds must pass between each attempt. Now, with the other framework like Poly, you have much more finer tuning on all these options. You can even choose which algorithm to use to add the delay to make sure that you avoid to just trying to reconnect when the connection is not available. But I kept the code very simple, so it will be easier to understand. And then we have 3 options, as you can see here. So the first test will be when, again, I execute my query, opening and closing a connection only when I need it, and as soon as I finished executing my query. And then between the first and the second query, there are 2 seconds delay. Then the second test, the second thread, is where I keep the connection open for 2 seconds before using it. And the third test is where my query will actually take at least 2 seconds to be executed. So let's see what happens when we run this code. So let me clear that, make some space, and let's go. Oh. Okay. The application will start, it will connect to the database called a resiliency test, and as you can see, there are 3 threads. Each one simply, executing a very simple select and reporting which kind of service level objective we are. You see everything is working. Every second they connect, and every 2 seconds they connect and do something. Now let's go to the database and try to change the service level objective so that basically I'm just simulating the fact that, well, actually, I'm simulating what could happen in real life, right? Because you have an application running, you notice that you need more power, so you want to upgrade your service level objective. So we move from S0 from S1 in this case. So let me execute this, and let's go here and see what's happened. So you will see nothing is happening. Okay. Just finish saying that now we have a couple of threads that were trying to execute something while the database changed the service level objective. Now we wait for 5 seconds. After 5 seconds, everything starts to work again. Now the interesting part here is that the first thread didn't get any error. Only the thread 2 and 3 get errors, right? Why? That's happened because the first thread open the connection, execute the query, and close the connection in the fastest way possible. So it's very unlikely, if the query is very fast, that you get an error exactly while you are executing such fast query. The other thread, for any reason, were keeping the connection open much more than the thread number 1. So you saw that there was some work for us to do. So, for example, trapping the exception and making sure that we fixed everything. But as you saw, if I, of course, would have created a real application, I wouldn't have surfaced this error to the end user. And yes, the end user, the only thing they would have experienced would have been just a little bit higher latency in normal activity, and that's it. No crashes, no big errors or unpleasant messages. So that's very important. And of course, I can now go back to my first and S0 original service level objective, and again, everything will work nicely again. So very simple example. Code is really pretty easy at the end of the day. And again, you can even use Polly to make it even easier, or Tenacity if you want to use Python. And that's it. So just make sure that right from the start, from your application, you write code so that it's resilient to this connection. Okay, now I can stop this, and here we go. So let's move to the other the next slide. And so let me go here and present again. Okay, so connection resiliency is one. Now the second one, and it is super important, on par with the connection resiliency, to make sure that users have a very good experience also when using a cloud application, is try to create applications that are not chatty. So what means for an application to be chatty? Well, before defining that, let's remember that when you are creating something on premises, I think that every one of us followed into the idea that we basically don't have network latency. On premises, usually network is so fast that you don't really take that network latency into account, because it's usually well below the millisecond range of latency. And for latency, it means from when your application start to send a message and when actually Azure SQL receive it, right? So there is a latency here. On premises, usually below milliseconds, so it's almost like not having it. In Azure, things are quite different. Typically in Azure and in general in the cloud. So if you have an application running on a VM, let's say, or an Azure function or a web app, there is a little bit more delay of when your application actually sends a query and when Azure SQL gets it. Now, we are trying to do our best to make sure that that latency will be below the millisecond too. But right now, depending on the region, depending on maybe your application is in a different region than your database, latency can be up to 1 or 2 milliseconds, right? So in that case, every time you send a command to Azure SQL, that 1 millisecond adds up to all the other commands sent to Azure SQL. So if instead asking for, select from a table where the where clause return 1,000 row, you basically execute one command that returns 1,000 row. So you just wait for 1 millisecond for the command to reach SQL. And then let's say it takes 100 milliseconds to fetch the row and send everything back. But still, 1 millisecond is basically nothing compared to the real time needed to execute the command. But what if instead of executing one command that returns 1,000 rows, you execute 1,000 commands, each one returning 1 row? The single 1 millisecond must be multiplied by all the commands, right? So basically, you will just wait for 1 second just to wait the command to go back and forth. So this will, of course, increase a lot your latency. If you are moving an existing application, maybe a legacy application on the cloud, it could happen that your application is doing a lot of requests to SQL Server, and when you are on the cloud on Azure SQL. So, for example, we had found that there are some applications that actually do from 500 to 3,000 or even more queries for each business transaction, where business transaction means, for example, fetching an order, information, fetching a client data, showing something on a UI. So, of course, if you have, let's say, 1,000 queries that you need to run to open up your form, your web page, and you are on premises, the bar that we'll see on the left, that is blue, will move to the green one very fast. Like, it's fast enough that no one will complain. But if you move everything on the cloud, you will see now that the bar from blue will become green in a way slower fashion, right? And if in your application, you need to execute this kind of business transaction more than once per UI, chances are that the user can, wait just 3, 4, 5, 10 seconds just due to latency and chattiness. So the message here is make sure that you use as much as possible a set-based approach instead of sending, 1,000 times one row. Send one set of 1,000 row, but one time. That's completely different. That will basically completely solve the network latency problem. So how can you do that? Like, for example, let's say you have a storage procedure and you need to insert 1,000 rows, and you know very well that storage procedure, or maybe you remember from the past, the storage procedure cannot accept arrays or tables, right? So how can you actually send a set of 1,000 rows as an input to a single storage procedure? Well, there are ways to do that. One is with table value parameters, which actually allows you to send a table as a parameter for a storage procedure. But not all languages support that. So in order to support that special parameter style, the client, for example, the .NET client in this case, needs to be aware of this special parameter. And .NET, of course, supports it. But for example, Python doesn't. So with Python, you could use JSON, because JSON, it's perfect. You can just you can just serialize your array into a JSON and then send it over the wire. Storage procedure can easily open JSON, and since JSON is actually an array, you just have actually passed an array to a storage procedure, and that's it. Or you have the bulk insert. Now, to show how these can impact the performance, I prepared an example where I show not only these 3 cases, but many more. So you can have a real glimpse of what means to use the correct tool to transfer data to Azure SQL. So let's go to this sample here, network latency. I won't go through the code because we don't have enough time, but again, all the code is available and it's pretty easy. Basically, I'm loading 1,000 rows, right? I'm looking for the fastest way from my on-premises machine right now, so where latency is even higher, to load 1,000 rows as fast as possible in Azure SQL. So let me go back to the correct folder and 07 and just run the sample. So I have to go .NET. Okay, so let's run the sample, and basically you will see that all we are doing is try to insert 1,000 insert. The first time we are doing literally calling 1,000 times the storage procedure that will do one insert. The second, and as you can see, it's pretty slow, right? Because from my machine, where latency is very high compared to what I have on Azure, it will take something like 20 or more seconds. And maybe more because I have kids now playing Rocket League, so maybe it will take more than that. Anyway, plus we also, 34 seconds. So usually it was 20-something. There are other solutions that allows you to actually send a list of objects as a parameter to a storage procedure, for example, using Dapper. But actually, behind the scene, they are really calling the storage procedure again 1,000 times for you. It's simply a little bit of code sugar to simplify your code, but behavior is the same. So it will still take 30-something seconds. So the trick is, for real, sending one array of 1,000 rows to the storage procedure. And that is something we can do with a table value parameter. And as you can see, the difference in time is absolutely amazing. JSON usually is on par with TVP, but again, I think today between me streaming, kids playing, my local latency is very low. It's very, very high. And there are other options like using raw constructors. But using bulk copy, that is really, really, really fast. So we went from 34 seconds to 0.8 seconds to pass exactly the same data, right? So just to give you an idea how higher the performance of your application could be if you choose the right way to send data to Azure SQL. So this is very good to keep in mind, because it can completely change the way your user will see the application from a performance perspective. Now, let me go back here and see. Okay, no questions so far, so perfect. So let me move now to other slide where I also run some tests, of course, on Azure, moving data from Azure VM in the same region to Azure SQL in the same region. And as you can see, of course, performance are way better than what I could do from on-premise to Azure. So I can move 3,000 rows in only 4.5 seconds, even using a very basic loop. So not too bad, but still it's 5 seconds. But if I move to bulk insert or TVP or JSON, all these choice outperforms the brute force approach of 3,000 command, 3,000 insert. This is one command with 3,000 rows. And as you can see, the improvement is amazing. So this really makes difference, create a huge performance improvement for your application. Now, another thing that will really help your application to scale and, again, to get a much better performance from a user perspective is using the recommitted snapshot. Now, luckily, this is done by default. So this is very important for you to know, because it's a different behavior by default than what we have on premises. On premises, we have to keep a default that is compatible with everything that we have done in the previous year. In Azure SQL, we decided to go with what we call the read-committed snapshot that will immediately unlock better performance for your application. Let me show you how in a very easy example. So let me take a couple of queries that I have here. So let's take this first query, or maybe I already have, nope. So let me connect to the wide word importer standard database, our well-known sample database, and let me connect twice, one because I need two connections. So I'm simulating a case of concurrency where I have two different applications, one that is trying to update some data, and the other that is trying to read some data. And let's say that for some reason, the application that is trying to change the data is somehow slower due to latency, due to the fact that I open a connection and then I started doing something else before executing a command. So in both cases, let's see what happened. So this is the data I already have in my table. So I have some cities available in my database. I have Bellevue, I have Sqlclient, I have Redmond, all cities around here in Seattle. And let's say that one connection, one application start a transaction and then start to say, okay, I want to insert some new data. I need to completely delete Bellevue for some reason. I need to update, this specific row for Sqlclient. And of course, all this data, all these changes will be available to that application that make those changes, because the application is, started the transaction, all the command being executed are in the same transaction. So here I'm seeing the changes. On premises, what would normally happen if another application start to use the database, for example, trying to get a list of, all the location in the city called Sqlclient, Redmond, and Bellevue. Well, that's exactly what will happen. The application will hang, because by default, and this is not something you would normally specify on premises, but this is the default behavior on premises. Read committed lock, which means that the application will stop and wait for the data to be committed or roll back, because only the data that has been committed, that's why it's called the read committed isolation level, the isolation level we are using, because only the committed data are allowed to be sent to anyone asking for it. The problem is that here we are waiting. In theory, since this data is not yet committed, what we could also do is just read the old data, the data that it was committed before. the other application started the transaction. So this is exactly what happened in Azure SQL. By default, without specifying anything, you will be able to read the pre-existing data, the data that existed before anyone started to try to change anything. So as you can see here, immediately my application will be more responsive because it doesn't have to wait for maybe a long transaction to be finished. So this is pretty cool because without literally doing anything, by default, if you are moving an application, that will have better performance, or at least better perceived performance. Or if you are just starting in the cloud, you have this beautiful behavior for free without literally doing nothing special. Now, other important things to know when you are working on Azure. Updates and deletes are, of course, something that you will do every day in your application, but they have a little bit, overhead, a little bit of overhead because in Azure, we have something called accelerated data recovery, which means that, let's say you run a transaction, and the transaction takes hours to complete. But at some point, someone that you may not be aware of, but starts, maybe your database administrator, or even an automatic system alone, starts to upgrade the database from S0 to S1, or from P0 to P6. Now, if your transaction is being running for an hour, usually what would have happened is that we have to roll back the transaction, and normally that would have taken exactly the same amount of time. That cannot work in the cloud, of course, because it's not that I can ask a database to move to a higher tier now and wait maybe an hour before that happens. So we had to create a new technology called accelerated database recovery, which as soon as you ask us to interrupt transaction, we can immediately cancel it. So we don't have to wait for the redo to happen. We can just say, okay, transaction canceled, completely undo everything you have done, and using the version that we kept, that you also saw before with the snapshot isolation level, we can immediately give you the version that existed before someone started doing the changes. Of course, this is as an overhead, which means that deleting updates can result in to be a little bit slower than on premises. So one way to solve that is, first of all, to avoid very long transaction. If you cannot avoid, so if you have to delete 1 million rows and there is no way that you can delete that with other technique, later I will show you one. One option to avoid to use a lot of resources, keep locking, maybe even locking the entire table for a long time, is to delete the row in chunks. So basically doing a delete top n and do a loop until the rows are deleted or updated, or use a link called row lock to make sure that Azure SQL always put the lock on each row instead of locking the entire table. Of course, this is a kind of a trade-off between concurrency and memory usage. So this needs to be taught a little bit, but that's important to keep in mind in case you really need to delete, 5 million rows out of 6 million that are in your table. Another thing that you want to keep in mind, which is very common in application, is that many times you want to delete or update something and then return the values that has been deleted or updated to the end user, just to say, okay, this is the data that we have deleted. So normally what people would do is, first of all, run a select that has the same where clause that will be used in the update or delete, and then update or delete effectively the rows. This is an issue, of course, because between the delete and the time when you actually do an update or a delete, between the select and when you actually do an update or a delete, may pass, maybe a millisecond, maybe a second, and in that time things can change. So probably you want to create a transaction to make sure that everything is used is executed as a whole, and so you don't have inconsistency. But a big transaction means locking, and locking means potentially concurrency. So how can you solve the problem without having to pay for this in some way? Well, there is a very good option that you can use, that is the output clause. So for example, you can do delete from and output to, so that the rows will be deleted and automatically the result will be sent to the output, just like if you would have executed a select statement. So let me show that. It's pretty interesting, and I recently answered an email, a question on that on Stack Overflow. So it's a very common request. I can close all this stuff here, and let me open the example. It's very quick and easy. Here we go. Move to database where it has all the data that I need, but I don't think I'm going even to execute the code. I just want to show you, maybe I will execute the delete one. I just want to show you how can you do that. So basically, this is the trick to do the delete of a big number of rows just by deleting them in chunk of 1,000 in this case, to make sure that the transaction is always small and you don't log too much. But what I really want to show you is this. So let's say I have some data in my order table. So let's say, for example, I want to delete all the orders done by clerk 1. So what I would normally do is something like that. And of course, if I do that without the output clause here, I will just delete the data and I won't be able to get the output. But if I do that instead, I will delete data and I will get the output. In just one transaction, no need to select anything, no need to create explicit transaction. So that's very nice, because you can always return the data that has been affected while you are actually changing database. And this is even better for the update. Let's say that you really want to show what kind of update has been done to the database to your user. You can do an update, and by outputting the primary key, and let's say here I'm just changing the comment, right? So I want to return the previous comment, so the comment that I updated, and the current value. So I can do that, and so I can show to my user, okay, I updated this comment for this order to comment here. So this is very nice, very handy. Will make your code way simpler, because you don't have to deal with opening a transaction, executing a select, then executing the update, closing the transaction. Your code, even your C# or the question on Stack Overflow was done using Tedious and Node.js. Instead of being like, I don't know, 10, 15 rows of code, will be probably 1 or 2. So way to go to simplify not only the database code, but also your application code. And of course, all these examples are available in the GitHub repo I'm using. Now, another very common requirement is how you can load data into Azure SQL. Maybe you have a CSV, maybe you have a JSON data, a JSON file, and you want to import it in Azure SQL, or in some cases, you even just want to query the external JSON file without importing it in Azure SQL. Is that possible? Yeah. So you have two options here. You can quickly import data that is, let's say, sitting, for example, in a blob store using bulk insert or open roset, or you can just read the data that is sitting in a blob store using, for example, select from open roset. These kind of topics are very common. So I created not one but two repositories specifically dedicated on to show how you can quickly import data into Azure SQL. One is exactly the one I will be showing you. If you are also into big data or using Databricks, I also created a dedicated GitHub repository where you can see how to really quickly load data from Databricks into Azure SQL using table partitioning, partition switching, and all the most advanced technique to really make it go as fast as possible. So that will be something that will be very useful if you are also in that area. So the repository is that I'm using right now is not the samples, even if I put a link to the correct repository here, and the sample is this one, Azure SQL DB import data. So you have different samples on how you can actually import data using, for example, the BCP on your machine, using bulk insert on Azure SQL, using PowerShell, for example. What I'm going to show you right now is a very simple example on how to just use pure T-SQL to import data. So let me move here. What I'm doing is, let me clean up everything. Perfect. And so I'm just, okay, let me, that's fine. Okay, so what I want to do is, that's probably not the database. Yes, I have to go to import sample. That's the database I usually use for this kind of example. Here we go. So let me clean up everything. Nice. So let me be sure that everything is good. Okay, so what I want to do is import some data that is sitting here in my Azure Blob Store, and specifically into this folder, into this container, right? So what I would normally do is just right-click, get the shared access signature, copy, create, and copy the query string. Okay, now I just have to create, first of all, the what we call the scope of the credential to keep the secret somewhere. Make sure that you remove the question mark at the beginning and execute that so that you can safely store the shared access signature into Azure SQL. And that will return an error because since these are sensitive data, it needs to be encrypted. So we need to create a master key before. So I'm creating a master key. Now all my secrets will be safely encrypted. And that's it. I have stored safely my shared access signature. Now I want to create an external data source that points exactly to my account and container, and saying that I want Azure SQL to be able to access that container using the credential stored here. With that, I can just go into the import demo and, for example, import the customer table I have saved before, or someone exported for me. But also, as you can see, I also have JSON data here. So let's say I want to read the JSON file without importing, for example. I can do that. Select from a column called bulk column, open row set. And this is just the file I want to read. This is where the file is available, and that's it. Here is my JSON file. This is the content of the JSON read directly from Azure Storage. Of course, this is JSON, so I can probably see it as a key value pair if I want, just using the OpenJSON function, or I can even turn it into a proper table by using OpenJSON with the with clause. And as you can see here, I'm really literally reading a JSON file, but treating it as a table, even if this table doesn't exist at all in Azure SQL. There are some rough cases I found. For example, there are in some cases situation where JSON is exported like a concatenated JSON. So you have one JSON document and then some space and then another JSON document. This is not a valid JSON, right? Because we have just concatenated several valid JSON document. But sometimes I have found this issue. So how can you do that? Very easy. I can still import my file. And then, for example, in this case, I know that I have to split each row using the line feed, and that's it. Now I have each JSON separated into its own column. And then if I want, I can then use OpenJSON to turn that JSON into a table or extract the data I need and do everything. The bottom line here is that I'm always reading from the storage and not from the database. And what if instead I want to import data? Let's say I have my customer table. I want to quickly import some table data that has been exported in a flat file format, so kind of a CSV. I can just do bulk import the file, again, the data source, some information on how to split the fields, and that's it. Now my data will be quickly imported into SQL, and now I can just manipulate my table with the data imported. I can also avoid to import data if I don't want to import my data into a table, but I want to run some query on a CSV file, on a flat file. In that case, I need to have also a format file that will actually allow Azure SQL to understand that this column is a string column and is named C address. So this format file is something you need to provide, and will look like something like that. So if this is the file I am giving as input, how can Azure SQL can read this file? And here it's basically the rules. The first column is a char of 50. It's divided by the next column with a pipe, and I want to call this column key, and so on. So with that, I think we are almost done. I think I have time for another demo. I will just do this one, and I think that we are pretty good. So, sorry.
Just sorry to interrupt. Do you see your screen freezing? Do you feel that?
Oh, you see my screen freezing? Oh, man. Oh. Can you see now? I'm projecting the SSMS, SQL Server Management Studio.
I see Visual Studio Code, Visual Studio.
Management Studio, so a bunch of data with open row set.
It says from open bulk import demo user JSON.
Right. Okay, so maybe it was a temporary issue. Okay, so let's see if we have enough time. So let's see. Let's go here and let me take the partition sample. Yeah, probably I won't have time to load and run everything, but I can just show something. And then everything it's available on GitHub, so you can really do it yourself. But what I want to show is that let's say you have a table and you have a big table, like in this case was a 75 million rows table. And for some reason, at some point, you want to delete all the rows of a certain date. If you have partitioned such table so that, for example, you have let me pick the code here. Here we go. You can basically create a table such in a way is partitioned, means that each order that is done in a specific here will actually be saved in a specific partition. One thing you can do is actually do something like that. Truncate table and specify the partition. This means that basically you are completely wiping out that partition. But if that partition contains all the data of a specific day or of a specific order or of a specific customer, you are basically just have found a way to quickly completely delete a bunch of data that may need to completely reload in a very fast way. This will always take some milliseconds because basically you are completely dropping all the pages related to the partition, which is completely different than deleting. So this is much faster because we're just dropping pages instead of deleting rows. So this is using partitioning even in the cloud. It's very useful because it allows you to do this kind of set-based manipulation very quickly. For example, you can even completely move one partition into another table and do the update and move the table back into the original partition. So these tricks allows you to quickly do delete and update that I told you before could be slow if you need them on a really huge block of data. So partitioning is not only useful on premises where you normally you would have used it to send data to specific file groups, which usually would have resided on a specific disk drive to maximize the IO throughput. Of course, this is not needed in the Azure because you don't manage the file, but still it's needed because, for example, it allows you these quick, tricks that allows you to quickly move data around without actually moving data, but moving pointers, which is much faster, but still produce exactly the same result. Also, the sample is completely available online, so I think we just have a couple of minutes for questions if you have any. Let me just go here, and yeah, I think I show a lot of stuff, but yeah, I just wanted to make sure that you see all the important points so that you can then go and do it yourself on the repository that is available here. So this is for example, this is the repository you want to reach. But I guess there will be a way for giving you the slides, Simon, so that they will be made available and people can download the slide. And every single demo I did is available in the repository, so you can really try it on your own.